of these non-standard factoring problems where we don't have a greatest common factor, a GCD. It's a 5-termed expression. If you'll notice here, there's nothing common to all 5 of these terms. So that's normally how you would start a factoring problem, is if there's a greatest common factor, you factor that out and then see what's left and work from there. We can't do that here. So we have to resort to other measures. Now, if you take a look at this identity, this well-known identity right here, that if you have a binomial squared, you have this 2 cross term in the very middle of it. So that's exactly what happens right here. You see, if you take a look here at the 2BC, it really belongs directly in the middle of this expression right here, right? Whereas if you took the 2BC and placed it right here, you could use this result right here to factor it. All right, it turns out that the A, B, and the AC would group together and the A would factor out. So you see, the key to solving a problem like this is look for a rearrangement. So let's get to the next screen and see how that works out. All right, now this is the original problem, okay? This is the original problem. And so what we did is we rearranged it based on what we just mentioned. See, if we rewrite it like this, b squared plus 2bc plus c squared. All right, now I'm just coming down to the next line here. And I wrote down that identity just for reference. You can see that this part right here that's highlighted would correspond exactly to this piece right over here. The letters have changed, but it's the same essential structure, right? And so what we do is we take this left-hand side, the a plus b squared, and put it right here. So you see how these 3 terms right here, these 3 terms that I'm hovering over, got replaced by b plus c quantity squared. All right, now that's advantageous because notice that when you factor these 2 terms as a group, and this is called factoring by grouping, folks. You group the stuff together in a way where you'll factor each individual problem and then get usually a common binomial factor or some common factor. And that's exactly what happens right here. Notice that b plus c is present here and it's present here. All right. And so what we can do is we can factor is that going to fit? Yeah. So you got a b plus c sitting in this term and a b plus c present in this term right here. And so you can factor that out. Now notice I used the square brackets to make this more readable. I think that's useful. So again, a lot of math is just reversible. B plus c times b plus c is b plus c quantity squared. And of course, a times b plus c is equal to this expression right here, which was all equal to the original problem rearranged. And so the blue output here is your result. We have factored it. It is the quantity b plus c times the quantity b plus c plus a. Alphabetically, people like to write that as a plus b plus c. It doesn't really make any difference. But again, folks, this is called factoring by grouping. And it works for these very long problems where greatest common factor, it can work. The problems really have to be set up to work, basically. But it works in general, or it's something to try in general if you have 4 or more terms. All right, hope you enjoyed that. I hope it helped.